Well, welcome to this study guide for the AZ-700 CERT exam prep. If you've already finished the first three sections, congratulations. It's a lot of material to go through. There's still quite a bit to address, though. So in this video, as you know, my goal is to give you a high-level introduction to the objectives in the AZ-700 certification exam. You can listen to this while you're eating your lunch, where you're riding your bike, maybe you're just spending some time as the workday winds down doing some self-education. Wherever you're doing this, just keep in mind that the focus of these study points all relates back to the stated objectives for the AZ-700 exam. So we're talking about designing and implementing Microsoft Azure networking solutions. So in this particular session, what we're going to do is focus on the fourth set of exam objectives, and that deals with securing and monitoring your Azure infrastructure. So let's get started. Azure Firewall. So Azure Firewall, as you might imagine, is a managed cloud-based network security service that protects your Azure virtual network resources. It is a fully stateful firewall as a service. It has built-in high availability, and because it's a cloud service, it has unrestricted scalability as well. So organizations can leverage the premium features of Azure Firewall. So again, we're getting into SKUs and features within SKUs. But the premium feature has things like IDPS and TLS inspection to prevent things like malware and viruses from spreading across networks, either laterally or horizontally within the network. So in order to support those performance requirements, Firewall Premium uses a more powerful virtual machine SKU. The premium SKU also complies with PCI DSS environment needs. So if that is a requirement in your environment, you'll need the premium SKU. When you set up a firewall and you have firewall policy, rules are organized inside rule collections, and they are contained in rule collection groups. Rule collections can be of one of three types. So it can be either DNAT, in other words, destination network address translation. It can be network, or it can be application type. So application rules are always processed after network rules, and network rules are always processed after DNAT rules. So that's the order that those are processed in. Controlling outbound network access is also an important part of an overall network security plan. So for example, you may want to limit access to a specific type of website, maybe gambling websites or so on. One way that you can control outbound network access from an Azure subnet is with Azure Firewall or Azure Firewall policy. So when you have this type of configuration set up, you can configure application rules that define specific FQDNs that you allow to be accessed from a specific subnets. Or you can have network rules that define source address, protocol, destination port, destination address for certain types of behaviors. If you have multiple firewalls, if you're managing multiple Azure firewalls, it can sometimes be difficult to be continuously changing firewall rules and keeping them in sync. And in order to help with that, Azure Firewall Manager is available in Azure Security Center or Microsoft Defender for Cloud, and that can help you to solve those problems. So Firewall Manager can provide security management capabilities for two different network architecture types. So there is the concept of a secured virtual hub. That is the name given to any Azure Virtual WAN hub where security and routing policies have been associated with that hub. A hub virtual network is the second type, the second network architecture type. And that's the name given to any standard Azure virtual network when there are no security policies directly associated with it. Make sure that you know that NVAs, network virtual appliances, which we discussed a couple sections ago, NVAs cannot be deployed into a basic hub. And make sure that you know that an application filtering rule can be used to control access to specific URLs in your environment, such as Google or whatever URL you want to control access to. A network security group in Azure allows you to filter network traffic to and from Azure resources in an Azure virtual network. So a network security group contains security rules that either allow or deny inbound network traffic to or outbound network traffic from different types of Azure resources. So for each rule that you define, you can specify source and destination, port, and protocol. Priority for the rules that you define here can be any number between 100 and 4096. So remember, the priority of 1 is not valid in terms of setting up rules within a network security group. The rules start at 100. 100 is the highest priority, and the rules are processed in priority order, with the lower numbers being processed before the higher numbers. Once traffic matches a rule, processing stops. And so as a result, any rules that exist with lower priorities, in other words, the higher numbers, if they have the same attributes as rules with higher priorities, the lower numbers, they will not be processed. An application security group, or ASG, as we abbreviate or use the acronym here, enables you to configure network security as an extension of an application's infrastructure. What this allows you to do is group virtual machines and define network security policies based on those groups. This allows you then to reuse your security policies at scale without having to manually maintain or explicitly define IP addresses. So the platform itself handles the complexity of understanding which IP address this is going to need to apply to, and the different rule sets that are involved. And all you have to really define is the business logic of the application security group. So in other words, to grossly simplify it, you might say, I want to allow web servers to talk to database servers, but I don't want database servers to be able to talk outbound to the internet. So you would define an application security group that fits that criteria. But because it's a broad definition, you don't have to recreate that each and every time you have that architecture, because you're not plugging in specific IP addresses or server names. The application security group logic is able to accomplish that on its own. So implementing and managing NSGs. Now, so keep in mind, we are switching back to NSGs, not application security groups. So network security groups, security rules are evaluated by priority using a 5-tuple of information. So we're looking at source port, destination port, and the protocol that's being used. And we take that information and make a decision about whether we're going to allow or deny traffic. Network security group flow logs are a feature of the Azure Network Watcher service. And this allows you to log information about IP traffic that's flowing through a network security group. So what are some common use cases for flow logs? Well, typical network monitoring, so identifying unknown or undesirable traffic, monitoring traffic levels or bandwidth consumption, filtering logs by IP address and port to understand how an application is behaving. You might also want to understand usage monitoring and how to optimize your network. So you may want to know who are the top talkers in your network. You could combine this with geo-IP data to identify who is performing cross-region network traffic, or who's initiating network traffic across regions. It can help you to understand traffic growth for capacity forecasting. You may need to use flow logs to verify network isolation and compliance in order to meet different compliance regulations. And then, of course, it's always good to have flow logs when you're doing forensics or security analysis. It's important to understand which IP addresses or hosts have been compromised, and you can export these flow logs into any SIM or IDS tool of your choice. So while flow logs are typically targeting NSGs, they are not displayed the same as the other logs. Flow logs are stored only within a storage account, and they have a specific logging path. So if you want to understand that logging path, take a look at the tutorial there in the Interpret NSG flow logs, the second bullet point. There's a couple of good scenarios here for you to think about. One of them is if you've got Azure virtual desktops in your network and they're not able to activate their licenses for some reason, you may want to make sure that there is a network rule for TCP on port 1688 as defined there in the Azure Firewall link. So it's not necessarily an NSG issue, but something to think about. What about if you have a group of machines that need to access a specific service, maybe an Azure SQL database? You could actually create what are called service tags, and those are described in the Azure Service Tags overview. So again, these are maybe not on the best slide to describe them, but they're good topics to understand and be familiar with. Web Application Firewall. Web Application Firewall provides you with a centralized location to protect your web applications from very well-known exploits and vulnerabilities. So this is going to be looking at things like SQL injection, cross-site scripting. Those are some of the most common types of attacks that a WAF will be looking for. Now, why do we need a WAF? Well, preventing that type of an attack in application code can be challenging, and it might require a whole lot of maintenance, patching, monitoring, and you may need to do that at different layers of the application topology. If you have a web application firewall, it helps to make that security management a whole lot simpler. A WAF also gives application administrators better assurance that they can protect against threats and different types of intrusions. WAF policies are configured to run in one of two modes, and you can kind of see it in the top diagram, the white box up at the top. There is detection mode and prevention mode. So when you run a WAF policy in detection mode, the WAF doesn't take any actions other than monitoring and logging the requests that match a WAF rule, and they log that into the WAF logs. When they're in prevention mode, the WAF takes a specified action if a request matches one of the rules. If there's a match that's found, then no further rules with lower priority are going to be evaluated. So a matched request is the stopping point for the processing of further rules, and then that match request is also logged in the WAF logs. Azure Web Application Firewall, which we have discussed to a certain degree already when we talked about Azure Application Gateway. It can also be used on Azure Front Door, and when it does, when you have that configuration, it provides you a centralized protection for your web applications. So it's going to defend your web services against those vulnerabilities and exploits. And it can also help you to meet various compliance requirements. When you install WAF or integrate WAF with Front Door, it becomes a global and centralized solution. It's deployed on the Azure Network Edge locations around the globe for your deployment. And so what it's going to do is inspect every incoming request that's delivered by Front Door at the network edge and help prevent any malicious attacks before they're able to get to the back-end resources. So when you implement a WAF deployment, you're going to have a set of managed rules. So there are a set of Azure managed default rules that include things like cross-site scripting, PHP injection attacks, remote command execution, SQL injection, protocol attacks, and so on. So the Azure managed default rule set is enabled by default. But you can modify or disable the action performed by that rule set if that's your choice. Those are the managed rules. There is also a set of custom rules. So you can control access to your web applications based on conditions that you define. So a custom WAF rule consists of a priority number, a rule type, the match conditions, in other words, how do I know when this rule should fire, and then an action. What do I do when this when these match conditions are satisfied? There are two types of custom rules. There are what we call match rules and rate limit rules. So a match rule controls access based on a set of matching conditions. A rate limit rule controls access based on matching conditions and the rate of incoming requests. So it's a good idea to know the difference between the managed rules and the custom rules, but also within the custom rules, whether to use a match rule or a rate limit rule is also a valuable piece of information. Azure Monitor is what we use to monitor our networks, in part at least. It delivers a comprehensive solution for collecting, analyzing, and acting on the telemetry from your cloud as well as your on-premises environment. So there are two types of data that Azure Monitor collects. And you can see that in the diagram. The two types of data in the center are metrics. So metrics are simply numerical values that describe some aspect of a system at a particular point in time. Logs contain different kinds of data that are organized into records, and they usually have different sets of properties for each type. So this might be event logs, traces, and these type of things can all be used to combine with your performance data and do analysis on perhaps web traffic or SQL traffic or whatever it might be. There's also a tool called Connection Monitor. So the Connection Monitor capability allows you to monitor communication at a regular interval and inform you when the reachability, the latency, if those change, or if the network topology changes between a VM and an endpoint. So for example, you might have a web server virtual machine that communicates with a database server virtual machine. You've got a connection monitor watching that. Now, someone in your organization may, unbeknownst to you, apply a custom route or network security rule to the web server or database server and break the ability for the web server to talk to the database server. Connection Monitor will detect that network topology change and alert you to it so you can act on it more quickly. Traffic analytics, the thing that's listed there at the bottom. So traffic analytics gives you visibility into user and application activity in your cloud networks. So it uses Network Watcher NSG flow logs in order to give you insight into traffic flow in your Azure cloud. So if you use traffic analytics with these flow logs, it allows you to visualize network activity across Azure subscriptions and maybe identify things like hotspots. If you've got a whole lot of traffic in certain areas, maybe you've got segments of the network that are underpowered and maybe need to be enhanced. You can identify security threats, open ports, applications that are attempting internet access, VMs that are connecting to rogue networks outside of your network. It can help you understand traffic flow patterns, again, to maybe plan capacity in a more effective way. And then it can help you to identify misconfigurations that might lead to failed connections in your network. In order to collect traffic analytics, you need to set up a log analytics workspace, which uses a storage location, and you need to collect data from network security groups using Network Watcher. So that's the answer to that the question there in the red box. Which components are required to set up traffic analytics? Again, you need a log analytics workspace, a storage location, and you'll need to collect your data using Network Watcher from your network security groups. And then our last slide on this section. So we talked a little bit about network security group flow logs. So again, a few of the key properties of flow logs. Number one, the flow logs are operating at layer 4 of the OSI model. They're recording all IP flows going in and out of your network security group. They are collected at 1-minute intervals through the Azure platform. They don't affect customer resources or network performance in any way whatsoever. They're written in JSON format. They show your outbound and inbound flows on a per network security group rule basis. They contain the network interface, the NIC the flow applies to, and then all the source address, source IP, destination address, destination IP of the protocol. All that information is contained in the flow logs. Azure Network Watcher, as we mentioned before, is a service that enables you to monitor and diagnose conditions from an end-to-end network level view. Network Watcher is enabled when you create a Network Watcher resource, and that allows you to utilize Network Watcher to monitor and repair the network health of things like VMs, virtual networks, application gateways, load balancers, and so on. It's always good, as you see down there in the lower left, the red box, to understand which type of logs you would use from a given source to troubleshoot connection issues or some other type of issue within your network. So it's a very good idea to be familiar with the different log types and what each of those log types, the type of information that it will give you. Next, we're going to move on to section 5. And that brings us to the end of this section. I hope it was beneficial for you. Please be sure to check out the study guides from Thomas Maurer and Charbel Nemnom as well. And you have the links to the study guide, the deck. So be sure to check out the other videos in this series. And I hope you do well on the exam.